to get in touch with our team and get assistance with chapters and subjects, we are offering the opportunity to WhatsApp us. These are the various numbers that you can use to WhatsApp us, and then we'll be getting in touch in order to discuss how to get you the needed assistance. So these are our contact numbers for us to get in touch and improve your understanding of your word. Any help that you need academically, we'll be able to help you in order to sustain your academic dream. Today we want to go to the next concept on concerning rational numbers. That's addition of rational numbers, right? So basically, before we do that, let's do some basic things about fractions. So if you have two fractions, a over b, you are adding it to something like c over d. The result of this addition, right, what we want to do by the addition is that we don't want to them to have separate, to be separate fractions, but we want to put them together. That's what basically we are doing an addition, right? So just like how we do normal 2 plus 3, you add them together, you get 5, right? Now for rational fractions too, it's possible to do that, but we are going to start with what we know from fractions. So what you do for fractions is that when you are doing addition, what you do is that you do, for the denominator, you multiply this among themselves, right, between themselves. So it's going to be b times d at the bottom. So but for the multiplication, if we just let it, we just do bd. So if I just do bd, it just means b and d are multiplying, right? But then you multiply the numerator of the first one, the one here, you multiply with the denominator of the other guy, so become ad, right? A will multiply d, and this one to also multiply there. So the sign is plus, right? So it become plus c times b, so that will be like bc, right? So this is the result. So if you have something like 2 over 7 plus 5 over 4, right, this one will be equal to, so at the denominator you multiply this by this, 7 times 4. So 7 times 4, that's what you do at the bottom here. So 7 by 4, and then at the top you do a bracket 2 times 4, because this will multiply this 2 by 4. Then the sign is plus, right? So you put plus between them and open another bracket for 5 to multiply 7. So it's going to be 5 times 7. This is how we do addition of this, and then basically you simplify this, right? You simplify this to get numerator. This 2 times 8 plus 35, 7 4 is 28. Then you further simplify to get 8 times plus 4 is 43 over 28. Okay, so we know that that's how we do addition, right? Let me properly do something again. So if you have something like 1 over 6 plus 3 on 5, for example, what you do is that you multiply, for the denominator you multiply this times this, becomes 6 times 5. But then for the numerator you do this one times this, right? So become 1 times 5 as a bracket. Now the sign follows, is a plus, so plus. Now 3 will multiply the denominator of the other guy, become 3 times 6. That's all you do. Then you now have 1 times 5 is 5 plus 3 times 6 is 18, all over 6 times 5 is 30. Then you just do this addition to have 23, right? 23 over 30. So this is the addition of these two. Okay, now let's send that into partial fractions too. Not partial fraction, I mean rational functions. For rational functions, we are adding this to this. So you do the same thing, right? They are all going to have the same denominator, where you multiply the denominators together, become, the first one is x plus 1, right? Multiplying x plus 1, right? So then this one, you multiply this to this to become 2 times, so 1 bracket 2 times x plus 1 from that bracket, plus 3 times x plus 1 from the other bracket. Okay, so there's something simpler we could have done for this case, right? Let me show you what you should have done. Let me go and give another example. This example before I go back to that. So for this one, there are cases if I have 2 over 7 plus 3 over 7. You see, the denominators are already the same, right? The denominators are already the same. So for that matter, you don't go through that long process of we only multiply between them only if they are different. But if the denominators are the same, you just do 7, you just write one of them is 7, then you add, you just do 2 plus 3. You add the numerators, you just write one of the denominator, become 5 over 7. So this is the final answer for this. Let me say that again. Let me do that again, right? I'm saying that if the denominators are the same, like 3 on 8 plus 2 on no 5 on 8, for example. So you see the denominator is the same, right? So you just write one of them 8, then you add the numerator 3 plus 5, then you get 8 over 8, which is equal to 1. But if you have something like 3 over 8 plus 2 over 7, the denominators are different. 8 and 7 are different. So for that matter, that's when you multiply this by this. You go to what I showed you first, right? Then do 3 times 7, right? 3 by 7 plus 2 by 8. Then you proceed with simplification. That's what is happening over here. Over here, the denominators are the same. S plus 1 and S plus 1. So if the denominators are the same, you just write one of them. S plus 1. Then you sum 2 plus 3. So become 5 over x plus 1. If the denominators are different for the two fractions, that's when you do the cross multiplication and multiplying the denominators among themselves. But then if they are the same, you just go proceed, write one of them, and then you just add the numerators. Let's do another question. Here you see this one clearly that is x plus 1 as the denominator for this first one, and x minus 1 is the denominator for the other one. So you see that they are different. So if they are different, we can just write one of them, because which of them are we going to write? They are not the same. Okay, so since they are different, we need to follow the due process. So we are going to multiply x plus 1 from the first fraction, multiplying it with x minus 1. Bracket means multiplication, right? So you multiply this and this for the denominator, and for the numerator, what do? We have to use the numerator of this to multiply the denominator of the other one. So you become x multiplying x minus 1. Then you bring in the sign. The sign is a plus. Plus the numerator of this, which is 2, will multiply the denominator of the other. That's 2 multiplying x plus 1. So if we have this, now we expand. The denominator is x plus 1 multiplying x minus 1. But the numerator, we need to expand. So if you expand this, you have x squared minus x plus 2x plus 2. I'm just expanding the brackets in order to simplify. So we become x squared, grouping like terms, x squared is only x squared. Negative 2, negative x and plus 2x become positive x plus 2. And the denominator is x plus 1 multiplying x minus 1. Right? So this is the answer for this addition. Okay, let's go for this one. Now for this one, you can see that the denominators are different. So if the denominators are different, we go by the usual. We multiply the denominators, right, between themselves, right? We multiply the denominators, and then we use the numerator of this to multiply the denominator of the other guy. So become x plus 2 to multiply the denominator of the other fraction. The sign is a plus, so plus the numerator of the second guy multiplying the denominator of the first fraction. So this is what you get, right? Then you simplify. The denominator is the same, right? So it become x plus 3 multiplying x minus 1 as the denominator. Then for the numerator, let's expand. We having x squared plus, no, it's not going to be plus, because so this is going to be to give you x squared, right? Let me use another color to so this is going to multiply this to give us x squared, right? And then this same thing is going to multiply -1 to give us minus x. Now we use 2 multiply this to give us 2x, and that 2 multiply -1 to give us -2. So we are done expanding this. Plus now 2x, right? 2x is going to multiply this, become 2x squared. 2x is going to multiply +3, become plus 6x. -1 is going to multiply this x, negative x. -1 is going to multiply 3, become -3. So those are for the numerators. Let me clean this top portion so that we can have more space to push this one up. So let's push this one up. Yeah, so now let's simplify the numerator. The numerator, s squared, grouping like there are 2s squared, so s squared plus 2s squared, that will give us 3s squared for the top. Then negative x plus 2x, that will be x. X plus 6x, that will be 7x. 7x minus x, that will give us 6x. So it's basically plus 6x. And then the constant terms, -2 and -3, that will give us -5, right? Divided by the denominator, s plus 3 multiplying x minus 1. Basically, that's the answer for this one. So that's the addition. Let's try this one. It's getting tougher, right? So for this same thing again, the numerators, right? You multiply the numerator of the first one plus 1 to multiply the denominator of this, right? That become x minus 3. The sign is a plus. Now x squared minus 2x to multiply the denominator of this is multiplying this, become x plus 2. So all divided by the denominators among themselves, s plus 2 multiplying x minus 3. As for the denominator, that's how we handle it. So let's focus on the numerator to expand. So you do expansion. Basically what I'm going to do here is expansion. So I have s cubed minus 3s squared plus x minus 3. I'm done with this guy, this side. I'm going to this side, plus this one is going to be s cubed plus 2s squared minus 2s squared, yes, minus 4x. So the same denominator, so I'm going to keep the denominator for now. I'm supposed to write the denominator at the bottom, but because of simplification, so we have s cubed plus s cubed, that will be like 2s cubed. So s squared, so positive s squared minus 2s squared, they all cancel out. So the only s squared, I have negative 3s squared. So what about these ones? So minus 4s, so positive x minus 4x, that will give a minus 3x, right? So minus 3, the only constant is minus 3 here, all over that denominator. The denominator is x plus 2 multiplying x minus 3. That's for the denominator. So we are fine with that. This is the final answer for this addition. So what you do is that you just group like terms and then you basically add them up. So let's do this last one. So it becomes, so this one also become, this will multiply this, become x alone will multiply the s squared plus 3x plus 2. The sign is plus 2 multiplying the denominator of the other squared minus 4, all over come s squared minus 4 to multiply s squared plus 3x plus 2. So these are the guys that we have. Now let's expand. Let me use another color to expand now. So become s cubed This x is multiplying, expanding with every term inside the other bracket, plus 3x squared plus 2x. I'm done with this. I'm going here, plus 2x squared minus 4, all over the same denominator, x squared minus 4 to multiply x squared plus 3x plus 2. So let me clean this and then push this one up. I'm going to simplify now. Going back to my black pen, simplifying the top, we have x cubed. Those are the cube, right? Hey, this one was supposed 2 times is x squared, right? 2 times negative 4 is negative 8, not 4. That was a mistake, sorry. So x squared, x cubed plus the x squared are 5, so become 3x squared plus 2x squared. That will be like 5x squared, right? Then the next one is 2x. So I just have 2x plus 2x minus 8 as the only constant. And the denominator is x squared minus 4 to multiply x squared plus 3x plus 2. So yes, that's how to do addition of rational functions. So in the next session, let's see how to do subtraction as well.